Okay, so that is that the release 17, and there has been a significant emphasis on integrating satellite access networks to terrestrial networks. So they're looking at how do we integrate satellite networks so to of integrating to terrestrial network. This integration necessitates a holistic design approach that spans multiple areas, including the RAN to services. And so they actually looking at how do they integrate satellite networks, okay, with terrestrial networks. So, oh, okay, okay, I get it. So there should be a scenario where you're supposed to have, you have a tower, a terrestrial network, so you can have basically what we do have is these are terrestrial networks which are already being able to carry services all across. So let's say we have a UIE, a UE, right? A user interface which is connected there. The user should be able to communicate with the terrestrial network, which is so the terrestrial networks are networks like Verizon, networks like Vodacom and all those. Those are all terrestrial networks, okay? Then what we're talking about is satellite communication networks like NORA1, SWAM. These are satellite communication networks. Okay, Spark Farm. These are satellites. So we're looking at a scenario where the same UAE can try to talk to a satellite and then be able to talk to the terrestrial at the same time, be able to have that kind of dual redundancy. Okay, so let's read on. So service and the system aspects to the core and terminal. The article provides insights and implications of incorporating satellite access networks as a new well, uh, 3G, which is the third generation partners project, run, and as a backhaul solution. We explore the impact of integration on networks architecture and performance, considering factors such as coverage, capacity, and latency. So it's a little bit similar to ours, and but what they are looking at coverage, they're looking at capacity, and then they're looking at latency when they go terrestrial. That is what this article is talking about. The approach radio. So I provide an inside implication of this, and then perform naturally measuring performance issues. So this could be the independent variables that they want to vary. The article also highlights the key issues in the third generation partners projects. I wonder what it is, but we will find out. Third generation partners project, what are the key issues, and outlines the prospective potential solutions in the context of the non-terrestrial to support 5G and beyond integrated architecture. That normally the 5G concept is a terrestrial solution. I've really not seen 5G being deployed over satellites yet, but I think it would be a great thing because we have a number of places in the world where we still don't have full terrestrial coverage, especially when you go to the rural areas back in Africa, villages and all those. Not every place is necessarily covered. You can talk about the Arctic, the Antarctica. Certain places are really not covered with terrestrial, and also concepts about how the Earth border that satellite communication tends to be the best. So if we can transfer 5G and stuff over that kind of concept, then it will be a good thing to discuss, bring into. So additionally, the article discusses the enhancements made in 3G release 18 and supports 5G and beyond the context of unscrewed aerial vehicles. All right. Yes. And when it also comes to the application of this solution over vehicular movements, okay, vehicular tracking is a great thing. Yes, more self drive solutions and all those kind of stuff. Satellite tends to have more coverage than that. Okay, so let's look at the demand for um, ambiguous network coverage and seamless connectivity is rising in the constantly changing world of telecommunications, driven by the advent of Internet of Things. That is true. Everything is actually connected now. With the introduction and evolution of 5G technology, mobile communications have undergone profound improvements that allow for greater data speeds, low latency, and extensive connectivity. So we look at right now everything is always about data speeds. How fast can I download information? How fast can I change information? Time becomes so much of a conscious, and then latency should naturally be close to zero. That is where the future is going. That basically boils down to capacity. The more you have capacity, the more you can have this kind of solutions being implemented. So this has given rise to the emergence of non-terrestrial networks. Yes, networks, that's satellite, as a promising solution leveraging IoT technologies. So we're looking at how do we use satellite networks to support IoT solutions. Okay, well, normally when it comes to IoT, using terrestrial solutions to solve IoT issues, it tends to be become complex and quite involved because IoTs are so spread all around that getting access to them, then building the coverage around them tends to be a little bit problematic. However, if IoT are being worked on by satellites, it tends to be very easy. It's just terrestrial, so you are good to go. Okay, so promising terrestrial leverage or carry. So the non-terrestrial includes two main types of airborne and speedborne vehicles. Geosynchronous and non-geosynchronous satellites play a significant role in the spaceborne category. Okay, so what it's trying to say here is that there are two types of satellites that we have. We have the geosynchronous and then the non, but we definitely going to know why they call them geosynchronous. So let's go along, let's stay together. So we have the geosynchronous uh, satellites, and then necessarily you will have the non geo synchronous, okay, synchronous types of satellites. So naturally, we have two types of satellites. Let's see what it says. And provide better connectivity service in regions where terrestrial networks face reliability. So let's see what it's saying. Pr- Platforms that have potential increase. Okay, so back here. Okay, so Jill, and then that's great. Play a significant role in the spaceborne category, while uncrewed aerial vehicles, uncrewed aerial systems, and high altitude platforms fall under the airborne category. All right, so these cutting edge platforms have the potential to increase work coverage, minimize coverage gaps, and provide better connectivity services in regions where all networks are. And then come and think about it. There's a concept where they say that when you are airborne, you cannot make calls. What do you think? Don't you think it's time? It's time the world should be able to communicate even when you're on airlines. And then the solution to that is definitely not terrestrial communication. It's going to be non-terrestrial communication using satellite communications, where definitely you should be able to make calls. All right. So if we have a UEE, a user on Earth who is on Earth and then is able to make calls with the terrestrial systems like the Verizon and stuff, and this same user phone can make calls with satellite, then when a member, when his brother is on a flight, he can switch to a terrestrial call, which I expect it to be automated, said that one should be able to make calls and then be able to talk to the terrestrial and they have those kind of communication, not necessarily go through. There could be issues about billing, but remember that Elon Musk, a company for I think this is platform or space. Space B and stuff, they already provide satellite communication, internet satellite communication. That's how come when you board an aircraft, nowadays it's a lot, you can subscribe to internet service while you're online. That's because the aircraft, it keeps getting internet access information coming from these non-terrestrial satellites. Okay, so high availability. So let's continue. So connectivity service in regions where terrestrial networks face reliability issues. Okay, so the importance of NTN in the context of 5G from a radio access network perspectives cannot be overstated. That is true. Terrestrial networks are a foundation of mobile communications, but they are intrinsically constrained by things like spatial restrictions, diversity, and all those kind of stuff. Deployment difficulties and economic constraints, and definitely, it costs billions of dollars to put satellites out there in space, and even the orbiting space, the space to do orbiting is also in tight competitions. So many other satellites are also there. So NTN provides a compelling solution to overcome these challenges and expand the reach of mobile networks to remote and hard to reach places. The capability of NTN to deliver coverage in rural, that's exactly what I was saying, in isolated solutions is one of the major factors influencing NTN's significance from the RAM perspective. So you still have the same concept that I want to talk to. So from the radio access technology background, most solutions or most phones tend to be hooked up onto the terrestrial kind of solution. We want to look at if it's possible for mobile phones to automatically switch between terrestrial and non-terrestrial solution, where non-terrestrial solutions definitely referring to satellite communication. And this is a solution that is in thought by the third generation partners group, which we call the 3GPP. They have released two books, two documentations, and what we are reading is an abstract coming from IEEE related to this solution. We want to see what we can do over there if we can build a research area around it. So provide compelling solutions to overcome these works, and then that recognizing the immense potential of NTN, the third generation partners project has been actively working on integrating satellite components into the 5G architecture. So the core is how do we integrate 5G components into the satellite architecture. For terrestrial, 5G has already been integrated. It's fine. Where in your core layer, we using solutions such as segment routing. Okay, we're using solutions such as segment routing, and of course, in segment routing, we have the SRV6, which is purely IPv6 capability, and then we still have the legacy SR MPLS solutions. All right, for those who still want to maintain their MPLS background. Remember that when we talk about SRV6 and SRV6 in general, you necessarily do not need MPLS. So MPLS layer 2.5 is dropped. In satellite communication, we definitely talking about all you need is to have your IGP communicating. All right, have your IGP communicating, and then we just use source routing protocols. All right, source routing protocol. We call them the SID, service set IDs. So use service set IDs to control where they go. That's a whole different topic altogether. So 5G on terrestrial is working perfectly. Most countries already deployed 5G. In Africa, Ghana, for example, I was part of a team that deployed 5G on the Ghana MTN network. But then when we talk about whether if this whole solution can be deployed terrestrially over non-terrestrial satellite like satellite communication. That is the goal of what we are discussing here, and that's the goal of what this work is all about. So let's see what they have to say. So recognize the immense potential of this. It encompasses a constellation of low Earth orbit satellites, okay, specifically considering UAVs and R, and as you cases within the NTN framework. In this aspect, 3 seeks to create a strong framework that solves the particular challenges faced by NTN and addresses issues like interworking projects. Let's see. Okay. Let me just keep this away here. I just want to make sure that we are not exceeding our time. So challenges and all that, and the efforts taken by three is a great what. And then the efforts taken by ES in this regard are crucial for the successful integration of this non-terrestrial into the 5G. So the whole goal we are discussing is how do we integrate 5G into satellite communication. That is the goal of the third generation partners group in their this year whole release comes. So let's see how that goes. So NTN technologies, including satellite and aerial platforms, can be leveraged for bridging the connectivity gap. To this end, the article provides insights related to NTN considering the three standardization. Okay, so the third generation partners project, they actually brought out standards to allow for this communication. So let's see. We present the run aspect and also highlight the enhancement outline for the 3GPP technical specification group. We present release 18 key issues, their potential solutions. We present UFA enhancements and registration process within the 5G and beyond framework. Finally, article is concluded. Okay, so let's see the topology that they actually brought out on how they are going to merge these two kind of communication systems. So what it's saying here is that 5G, of course, 5G users, you can find them here. Satellite network as a new run. Okay, that's fine. To the of course definitely it needs to have communication to the core, so it goes through 3G run radio. Okay, okay. Okay, so it's saying that we can try use the satellite networks to backhaul. Let's say you want to backhaul, which would be a very good solution. So this is a terrestrial node, and then for the terrestrial node to backhaul to the core network, where you're going to have the 5G core, things like the HSR, all those kind of stuff. What we have over there in the core network, where actual switching of traffic and all those kind of there's just all those kind of stuff. We could use satellite to back all this information. What mostly I'll be interested in will be to find out what is the transmission media what that they are using here. Normally, over the core, over the terrestrial network, you want to use either Ethernet, you want to use SONET or SDH or PDH as your encapsulation method at layer 2. For satellite communication, I'm not really sure at this stage, but definitely I believe that we will get to a point where this should become clearer. However, let's see what they are saying. So they are saying that they're going to have a 3GP management system. Management basically something like a network operations center or something like that. That will have the interfaces, and one will be how okay a RAM, so that will be plugged in. It could be any API connection into the radio access network. Okay, so that means that users will necessarily only have to be hooked onto the RAN network, and it's rather the RAN network which is going to have a back end connection to the 3GPP platform, the satellite communication. Okay, so the 3GPP could also act as a backhaul, that's a transmission layer. So at the access layer, you can have the radio talk to that. Okay, that's fine. So my initial concept, I was thinking that the UEE, the users directly talk to the satellites, which of course would be a waste of resources. Having it's better for them to still talk to, the biggest problem in rural telephony is not the sighting of these sites. These are so easy to sight them up, but the backhauling is always this issue. How do we backhaul the solution? How do we backhaul? That is where it becomes costly. So if they say that in a rural side they could host a tower over there, and then the tower could communicate directly with the 3GPP platform, which is necessarily a good thing, then it's a great thing. Yeah. So let's see. Satellite management system. Okay, so satellite transport network. Part of it. Okay, that is great. And then so this for backhaul, and then also the core network as well. So this is actually the whole 5G architecture. 'Cause in a 5G, you have the core. Later in some, I will be able to. I will explain what constitute the core layer of the 5G architecture. So in that same way, so the core could also have a connection to the 3G platform and so to relay that kind of communication. So a time is so what this guys what they are saying is that the time is coming where instead of using routers, switches, building an IP infrastructure for your backhaul, a time is coming where we actually going to use satellites to backhaul the 5G architecture. This is what the solution is. So use 5G, use satellites, non-terrestrial solutions to backhaul, and this would be a great thing for rural telephony or in areas where terrestrial solutions are difficult to find. So integration of satellite components in 5G architecture with the third generation perspective. Let's see what they say. So they've released 18 focusing on standardizing the integration of satellite-based networks into existing terrestrial architecture. That is great. Permit me to color this. Is so powerful here. Okay, good. By ensuring interoperability and efficient integration. So, when it comes to such kind of integration, the most important thing that we are all concerned about becomes interoperability, right? Interoperability is becomes the main issue. So, what is interoperability? Stability. All right. So it is actually about how, in a layman's term, I will say that, for example, if you have a Cisco device, okay, and then you have a Huawei device. Remember that we have vendor-specific solutions that they do. So they could have an interface on Cisco connecting to Huawei like this, and then you all have there are networks like that where you have Huawei deploy, you have Cisco deploy, you have multi-vendor. Most service providers do like multi-vendor environment so as to create monopoly. So if you want to create monopoly, then you want to have a scenario like this. So interoperability is where is it possible for traffic to be moved from Cisco into Huawei and then Huawei back, and then how are the traffic going to be encapsulated? How are the interfaces responding to each other? So to resolve this, how we solve this kind of issues is that's how come we have body like the IEEE, the ITUT, and the RFCs in general. So they create what we call standards. And what they say is very simple. Hey, if you want to do interoperability within vendors and that, make sure you all follow this standard. So I can give you a typical example of a standard, like if you're building SFP models, you want to do SFP plus, then everybody should necessarily consider the SFP plus, all right? And then encapsulation modules, like you should necessarily support things like, they are also concepts like, if we talk about, for example, spanning tree, STP, RSTP, VSTP standards that everybody should support. But what happens when a vendor supports something like the PVST? If I'm not very sure, yeah, and this is a Cisco proprietary solution. So if Cisco proprietary and you're a third party, you are coming in, then you have to fall on the concept of interoperability. And so interoperability becomes a very key feature when it comes to mixing vendors or communicating between devices of various vendors. So if we really want to integrate satellite communication into our terrestrial solutions, then it is true that interoperability becomes a very key important thing that we need to discuss. And that is why they're saying here that where are you? they actually stressing on the need to do interoperability with this. So, sufficient communication handover, 5. Okay, so next generation RAN. Okay, so 5G, the integration of satellite network with 5G beyond architecture brings forth new possibilities and impact on the 5G core. And this, yes, definitely, we have discussed this. We have discussed this aspect of it. So both from both backhaul and new access perspective, this section explores this impact and highlights the consideration made by the 3GP and standards figures, shows the standard delivery management and integration with the satellite management system, also ensuring that, okay, so let's look at what are the implications as you begin to do this, because this is a very beautiful concept or architecture that they actually want to bring out. How do we get 5G over satellite communication, non-terrestrial solutions? So let's see. Oh, come back here. Let's go. Okay. So a community and that's okay. So efficient and that. All right. So satellite NGR RAN is utilized as a new RAN GPP access introducing. Okay. So what they actually there's the building this concept NG satellite RAN. Okay. So it's utilized as a new RAN GPP access, introducing satellite connectivity directly to the 5G CN, with the satellite NGRN as a new access consideration arise regarding the integration of satellite connectivity with the 5GC. So 5GC, anytime when you see 5GC, we're referring to nothing else than the core network, okay, the 5GC core. It involves enabling direct communication between user equipment. So user is the mobile user, so that's the mobile user, and then the satellite. Okay, so the NG RAN. Okay, so the satellite NG RAN. So the satellite NG RAN is nothing else than the at the back end. It could be deployed in a RAN network to make sure that it has a seamless connectivity to the satellite, and it definitely future IoT characteristics major necessitates the use of different spectrums, and we will come to spectrums, what kind of spectrums they're actually communicating. Okay, so beware and support direct communication between IoT and services. So let's go down. I'm more interested in how they actually implementing this. So at this time, the overview is there. We know exactly what they want to do. Okay, impact on 5GC mobility management. So one of the key impacts of satellite NGN RAN on a 5GC is the realm of mobility management. That is very true. So in as much as we did talk about interoperability as the main issue, the other issue that needs addressing will definitely going to be mobility. So let me put that as a second point here. And mobility is really of a very important concern when it comes to designing networks. Okay, so we talked about the first thing that we need to address is interoperability. Okay, the second thing we need to talk about is mobility. And the question is, what is mobility? So mobility in a layman's term is how do you still get yourself connected to the network as you begin to move? And you know that a couple of things, there are concepts like multi-path feeding and stuff when it comes to microwave technology and all those kind of stuff. For example, if you are on your user plane, and then there's a car passing by, all right, your signal gets distorted in a certain way, so you begin to get information from different, and then this one we call them the I have forgotten the term, but it has a term that we call the slide fading kind of stuff. Okay, so mobility really becomes an issue. For example, if you're in a car and then you are speeding at let's say 27 miles per hour. All right. How your experience with the network communication should never be different from somebody who is speeding at 275 miles per hour. That necessarily means that at 275 miles per hour, the network really need to overwork itself to catch up to still maintain the pace and still be able to copy information continuously to sync with the information. So they actually great mathematical calculations around this concept of how how terrestrial communication do that. So when it comes to satellite communication and they are stressing on mobility, I really do agree. I fully do agree with them. Okay, in that part. So if you've been a research about this concept of deploying the 3GPP solution, all right, for the non-terrestrial network solutions, then these are very key important concepts that you are really interested in investigating. So so the large satellite cells compared to the terrestrial cells in